Chapter 14, Example 4. So once again, this is another design problem where we are given the logic levels of the input signals and the output signal, and we need to generate a circuit that will implement this equation. The problem says minimize device count, which we'll need to kind of play some games with this. And so let's just go ahead and do this. So once again, this is equation looks like it's in a POS, product of sums form. Here are the sums, they're being product together. That's going to be essentially an AND gate. There's my AND gate, and it's active low. Drop a bubble in that thing. I've got some OR terms there, and those are going to feed into this guy, and it's okay to do that right now. I don't have any constraints on the gates. I could put bubbles here, 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 and here, and it would be the same thing. I'm not going to worry about that, though I might have to put bubbles in the back end of this just to make the device count go down. So there's my circuit so far. I'm going to go ahead and write these down. Here's my A. I'll connect it directly. A sub pi, I need an A bar over that, so this isn't going to work. I am going to need an inverter in this one. So that's going to be A not sub pi using equivalent signals. B, I can tell by looking at it, it needs an inverter. B sub low, this becomes B sub high. This no overbar on the B matches the no overbar on this B. C, I can see I can connect that directly. C sub high, looking good on that. D, we'll just connect it directly, and I can see that's not going to fly. I'm going to need an inverter on that, so this is going to be D not sub high. And E here directly, it's not going to fly. I can tell it's not going to fly. And this is going to be E not sub high. That's working circuit. The issue here is I chose to use OR gates here. Since I want to minimize the device count, I'm going to redraw this circuit over here and switch this to a NAND gate, particularly the OR form of a NAND gate. Pretty sure that all I have to do is, because I have bubbles in the back end of this, is everywhere I see an inverter here, I get rid of the inverter. Everywhere I don't see an inverter, I add an inverter. I think that's right, and I'm going to go check it when I'm done. This is E sub low, it matches, no overbar there. This is D sub high, D not sub low. This overbar matches that overbar. A sub high is A naught sub low. There's my A naught. This B sub low is B no over. Okay, so this is an equivalent circuit. These two are equivalent circuits. This one uses essentially 3 less devices than that. It uses 3 less inverters. So you could argue this would be a better circuit, minimum cost, and all those type of things. The issue here is that in these problems you do have flexibility if they don't constrain which gates you can use.